Okay, so the first thing we're going to go over is function notation, and function notation says that we're going to replace the y in functions. So let's look at y equals 2 times x. If I say find y when x equals 4, then that means I don't know y, but I know that the x equals 4. Therefore, if y equals 2 times the x value, y would equal 8. So that would mean an ordered pair of 4 for the x, because that's what you put in, and you got out 8 for y. Another way to say that is instead of y, you use f of x. And you can use the same function, and that's just saying the function's in terms of x. And instead of saying find y when x is 4, I can just say find f of 4. And that means you put 4 in for the x. When you do that, you have f of x equals 2x, so f of 4 equals 2 times 4, and that equals 8. So you have f of 4 equals 8, which means that's your x, and that's your y. Okay. So with that being said, if I just said graph f of x equals 2x, then this is a linear function. You know that it starts at 0, so it goes to 0, and then it has a slope of 2. So up 2 to the right 1, up 2 to the right 1. Or you can go down 2 to the left 1, down 2 to the left 1. And then you would have a straight line there going through all those points. And that would be your function. So first I'm going to show you a different type of function, and it's called an exponential function. And we're going to say it's in the form of f of x equals 2 raised to the x power, which is different than 2x. So here you don't really know what this looks like. We don't have a shortcut as far as like it starts somewhere and goes up to right 1. But you can make a table and say, okay, well, what if I put in -2 for x, or -1, 0, 1, or 2? What would you get out for y? And then you could graph them. So if you did f of -2, you would actually get this. Sorry about that. Hold on just a second. You would get this. Y would equal 2 raised to the -2, 2 raised to the -1, 2 raised to the 0, 2 raised to the 1, and 2 raised to the 2, because you have to put -2 in for x. And what those values would be is 2 to the -2. If you recall, 2 to the -2, you have a negative x on it, you put it on the bottom, make it positive, and then put a placeholder of that. So you would get 1 over 4. So that would be 1/4. This would be 1/2. 2 to the 0 is 1. Anything to the 0 power is 1. 2 to the first is 2, and 2 to the second is 4. So if I graph those ordered pairs, it would be -2 1/4, -1 1/2, 0 1, 1 2, and 2 4. You could tell that that's not a straight line. If I put 3 in for x, you would get 2 to the 8th, so that would be another one. You could tell that it's not going up a constant amount. This is up 1 over 1, up 2 over 1, up 4 over 1. So it's doubling actually. It goes from 1 to 2 to 4 as far as the increase. So what's going to happen there is when you graph that, it forms a curve. Now, what happens over here? Well, if you think about it, what if I put in -100 for x? I would get 2 to the -100th power, which would be 1 over 2 to the 100th. Now, this is a super small number. 2 to the 100th is really big, but 1 divided by a really big number is really small. So what happens is this graph gets really, really, really close to that axis, but it never touches it, and that should be a straight line. You can see it better if I graph it on Desmos. So you can see that if I zoom in on that graph, it gets really close to the line but never touches it. And what that is called on an exponential function is an asymptote. So this actually has an asymptote of y equals 100. And what that means, or not 100, sorry, y equals 0. And what that means is that it gets really close to this line, but it never touches it. Okay. Alright, so now we're going to go over some transformations, which you'll need for this and quadratics. So here we go. This will make sense in a minute. All of it will kind of come together. But this is what you need in your notes. Okay. So the first thing, if you add a number at the end, well, what that means is that I take what I have and I add a number at the end. And you notice that the red line to the blue line, or excuse me, the red graph to the blue graph went up 6 units. So now instead of the asymptote being y equals 0, the asymptote is y equals 6, and you can see it never touches that. So if I put a number at the very end here, it shifts up b units. So whatever the b is, you go up that many units. So for example, if f of x said 2 to the x, and I said if I said f of x plus 6, then that would equal f of x is 2 to the x, so 2 to the x plus 6. That means that the exponential function that you graphed right here would go up 6 units. All of these ordered pairs would go up 6. So what do you think a minus does at the end? It shifts down b units. It would just go down. Now, this one right here, x plus b, that's with the exponent. So if f of x equals 2 to the x, then let me go to red again. F of x equals 2 to the x, and I said to do f of x minus 3. That's actually going to be x minus 3 is going to replace the x here. So it would be 2 to the x minus 3. Let's see what that does. If I do 2 to the x you can see that what happened is from the red to the blue, it shifted right 3 units. So right here it's 1, 2, 3 units. This ordered pair would be 1, 2, 3 units. Everything moved to the right 3 units. So if I have it plus b with the x, then that means it shifts. I'm sorry, I did that wrong. X minus b. I should be doing this one. It shifts right 3 units. Sorry about that. I should be down there. So if you have a minus b with the x, it goes right 3 units. What do you think if you have a plus b? It would shift left b units. And let's put a b right there. Okay. So a plus b would shift it left, and a minus b would shift it right. Now a negative b, or a negative f of x, that would be like taking the same function and then just putting a negative on the front of it. Notice what happens to the blue when you put a negative on front of it. The asymptote stayed the same, but everything flipped down. So this means it flips vertically. If you put a negative with the x, it flips horizontally. So if you notice, if I take that negative off and I put a negative with the x, it makes it flip horizontally here, across the y-axis. Alright, and if I put a number in front of it, a, if a is larger than 1, the graph gets steeper. If a is less than 1, but greater than 0, it gets wider. So if I just put a number in front, let's say that I wanted to put 4. So 4 times 2 to the a. Notice that it makes this become steeper quicker. If I put 1/4, you notice that here was the red one and it becomes wider here. It pushes out a little bit. Okay? So here is essentially the lesson. If I said f of x equals 2 to the x, in your mind you should be thinking that that function looks like that, because that's the parent function that we went over right here. Okay? So if that's the function we're talking about, what does this do? What if I said f of x minus 4 plus 7? That would translate to this. Instead of x, I'm going to do x minus 4. So it becomes 2 to the x minus 4, and then plus 7 on the end. So what that would do is go right 4 and up 7. So what that graph would look like now, to give you a sketch, and that's what you need to get used to doing, this red one would go right 4 and then up 7. You got to remember that that asymptote now would be y equals 7. This is the graph of this, but y equals 7 is just a line it gets close to and doesn't touch. So what would this one be? If I had f of x equals 2 to the x, what would this be? That would mean negative goes in front of 2 to the x, and then I would add 3. So a negative flips vertically and shifts up 3. So again, you're thinking this, and then when you flip it vertically and shift it up 3, the flip would go like this. That would be a vertical flip. And then to push it up 3, that would change it to about that right there. So that one would be every shift. It would be the flip and the shift up. So that would be your final step. So pause the video on the next one and see if you can get this without me helping you. Here's the function. It should be a 5. What is that function? you can do. Probably going to see if you can do it. Okay, I hope you can do this one. This means it goes left 5 because it's inside the parentheses. And this means it would go down 1. This 3, if you look at it as this right here, it's the A here. So since our number was 3, it's larger than 1, so that means it's a steeper graph. And this is a flip vertical. Okay, so your function that looks like this would go to the left, it would go down, it would get steeper and flip. So if it goes to the left and down, you would have the asymptote of y equals -1. Left and down, it would go somewhere right here. And then if you flip it, that one becomes down here, and it becomes steeper. Now these are not perfect sketches, I just want you to know where the asymptote is and in what vicinity that would be. I hope that helps with the function transformations.